we have started this company in 2018 with an vision to pass our rich experience in polyurethane in industries. We, as you know now, we have a good experience in this industry from the not only from the India, also from the international market, and we want to pass this knowledge to all our Indian customer and to increase their knowledge and fill the gaps where they are having regarding these PU machineries and equipments. So let's have a quick. Okay, let's have a.
May I request all the participants to please mute themselves?
Thank you, ma'am. Thank you. So let's start with the points which we are going to cover in this presentation today. So first, we will have a brief overview of low pressure machine, including its high advantages and limitations. This will give you an idea about the low pressure machine, how it works, what are the components used in the machineries, what are the advantages, what are the limitations. We'll learn through this things in this slide. Secondly, we go through the high pressure machine component and its what are the main component used in the high pressure machine and what components are important to for the smooth production for your product depending upon the different applications. Second, we'll also work we will understand the working of the high pressure machine, how this machine work. Will see all the you can say the parameters, all the logic, how this high pressure machine will work. Then we'll, after knowing the working of the high pressure machine, we'll see how to select the machine for the right application, whether it is flexible, whether it is integral form, or whether it is rigid application. We'll guide you through a right process to select a high pressure machine according to your tailored need. Then we will also talk about some innovation in this kind of machineries which are going through in the international market and why this innovation is important. What's our plan to bring this innovation in our machine and to support our Indian customer? So these are the points we are going to cover in this presentation. So I hope you will enjoy the session. Then let's start with the low pressure machine. This low pressure machine basically designed by a European scientist called Carl Hennecke in 1946. This is the start of mixing technology for polyurethane foam, and low pressure machine were among the earliest type of equipment developed for the polyurethane production. This system laid a foundation for polyurethane industry because that time this high pressure machineries were not developed. So these low pressure machines plays a very important role in the development of polyurethane products and all the machineries we see nowadays. So let's talk about the technology on which this low pressure machine is working. And this low pressure machine is based on the mechanical mixing technology. This mixing is happening through the stirrer in the mixing head. I'll show you the how the low pressure mixing head is look like. This is the low pressure mixing head, and you can see there is a stirrer. With the help of this stirrer, both the polyol and isocyanate mix together and it will give you the output, required output. There are multiple type of elements or stirrer are available in the market to cater different kind of applications. If I talk about the component used in the low pressure machine, the main component is a mixing head, which is I have shown here for your quick reference. Then the metering pump, which include the motor and the pump to transport the chemicals, both the chemicals, polyol and isocyanate from chemical tanks to the mixing head system. In this kind of machinery, basically a positive displacement pump or gear pump is used for the transfer of these chemicals. Talking about the automation or control panel, low pressure machine requires or have very minimal automation, and most of the operations were manual in this low pressure machine. Let's jump on the advantages and disadvantages or limitation of the low pressure machine. Like, it is a very simply designed machine, and because of less component use, it is a very cost effective machine. Keep the initial investment at very lower side, and it is a good machine for the companies like who is starting their uh, manufacturing plant. So for the startup, it was a good option earlier days. And as I told you, the design of the machine, simplicity makes it easy to maintain during the operation or during the production. Then the main point is the limitations. Why these high pressure machines are developed? Because because of these limitations of low pressure machine. Because here in low pressure machine, this mixing of polyol and isocyanate is happening at ambient temperature or little bit higher temperature, only through the dynamic mixture or stirring stirs. So the mixing is not so proper. Because of this, many time it leads to the poor foam quality, like density variation and surface defect. This kind of things we are seeing with the low pressure machine. Again, in low pressure machine, after every cycle or every shot, we need to clean the mixing head, and for the cleaning we need to use the solvent or other cleaning agent to maintain the machine workable for our next cycle or next operation. So during this cleaning process, also some part of chemical are wastage. So some part of chemical is going to waste during the mixing and cleaning. Also, this solvent is used for the cleaning. So unnecessary, it is increasing the cost of the overall production. Then we'll next move to the output accuracy. Because of this dynamic mixing, you cannot have a precise control on the output or ratio of this polyol and isocyanate. And if you want to produce a good quality product, then definitely this output, and you have to control on the machine short weight output, and also you have to have a control on the ratio of the mixing ratio of the polyol and iso. This you can say possibility or the features are not available or not so precise on this kind of low pressure machine. So generally, this kind of low pressure machine are used, as I told you, for the startup purpose or to the low end application where this parameter like mixing and all not so much important. At this place, this low pressure machine were used. So after that, based on the limitations of the low pressure machine, uh, the invention of high pressure machine is took place. And what is the difference, main difference between low pressure and high pressure? That is this impingement mixing. How this come into the picture? In early after 1950, there is a scientist called Dr. Arvin. He developed impingement mixing technology with the help of diesel injectors. So he used diesel injectors to mix this polyurethane component, that is polyol and isocyanate mixing. So so you can see here, just a second. Okay, you can see here, this is injector 1, this is injector 2, and this is the mixing chamber. Here, both the chemicals, iso and polyol, they are injecting through a injector or nozzle at high pressure. Because of this high pressure turbulence, we are getting very good mixing quality as compared to the low pressure machine. So this is the main change, difference in low pressure and high pressure machine. And based on this impingement mixing technology, companies in Europe, they have developed a new kind of mixing head that is totally based on the this impingement technology. There they have used this kind of nozzles for polyol and isocyanate, and they used high pressure phenomenon to mix this kind of uh, chemicals, PU chemicals. Because of this, we are getting a good quality, good mixing, good control of ratio, good control on machine short weight. So first straight head mixing head is developed. Here you can see this is the straight mixing head. In this mixing head, only one piston is there, and one piston is controlling both the flow. Both the flow means polyol flow also and isocyanate flow also. We'll also see how this mixing head works in our next slide. So here just to introduce you about what is the next straight mixing head and what is the L-type mixing head. So you can see here in the presentation, this is called L-type mixing head. In L-type mixing head, we use two pistons. Basically, this piston is called a self-cleaning piston, and this is called a pouring piston. So pouring is managed by this pouring piston, and mixing chamber is getting cleaned by this big piston called cleaning piston. We'll see also in detail, as I told you. Next, let's move to the next slide, which is the application. Here, I will not go into the detail of the applications. After this webinar, you can take this entire presentation from me. I can share with you. I will also share this presentation with Snehalata ji. She can also share this presentation to you. So here in this slide, I only want to give you the possible area or already where this polyurethane is applicable, like furniture industry, automotive industry, construction industry, application, refrigerator industry. Again, the energy sector also, sports, packaging, footwear. In if you see, the polyurethane is almost present in all the segments or all the industry. So we'll not go in detail of this application. Let's move to the main component of the machine, or whatever components is used in the high pressure machine. I'm going to give you a like indication or going to brief you one by one. So this is the basic concept or this basic flow chart of the high pressure machine. Here you can see the polyol tank. This is polyol tank. Similarly, this is the iso tank. Then on the board tank, we recommend to have a agitation uh, because in polyol you are having a pigment which can just settle down, and this agitator will help you to recirculate this chemical or mix this polyol and maintain the uniformity, the pigment settle down, prevent the pigment settle down in the bottom. So this for this reason, this agitation is required. Also, we suggest to have a agitator on iso side. Why? Because whenever isocyanate get contact with moisture, or it is not used in the longer period of time, it is get crystallized. The small part of the crystal is forming, and to break the breaking this crystal form is very important. So if you have the agitator on your tank, this will help you to maintain this isocyanate condition as well. Let's see how this agitator look like on the machine. This is a simple example like how agitator look like on the machine. Uh, Basically a combination of motor and a gearbox to control the agitator speed like 100 rpms and so. So this is very important part of the high pressure mixing head. Then level indicator also very important, and that also a magnetic level indicator is we recommend, because in many machine you can see a tube type level indicator, but this tube type level indicator over a period of time, say 1 year, 1.5 year or 2 year, it is get not visible properly the level of this. That's the reason we recommend this magnetic type level indicators, and this is a long durable which is very necessary for a long period of time and without maintenance activity on the machineries. So we'll also discuss this magnetic level sensor in detail in our previous in our next slide. Here I am giving you just a product overview so you can understand the machine component which is necessary on the machine. Next we move to the pumping unit or pumping group. It is the basically the combination of this pump, this is pump and magnetic coupling and motor. So here, the main and important point which I want to highlight is magnetic coupling. Magnetic coupling is very important on your polyol side also and your ISO side also. Why it is important, we'll discuss in our next slide. And this here you can have a look of like how this pumps and all entire setup look like. Let's move to the next, like heat exchanger. Uh, This is the heat exchanger and this is placed in the return line of the machine. This plays a very important role for maintaining temperature of the chemicals. Isocyanate and polyol, both the chemicals temperature need to be maintained in certain ratio, which is recommended by all the chemical manufacturer or chemical supplier. So this heat exchanger basically help to condition or maintain the temperature of the both the chemical during the summer or during the winter season. We'll also see the detailed working process and the temperature control system in our next slide. Let's move to the next component on our machine, that is uh, filters. Filters also plays a very important role, and there is a multiple type filters available in the market. We recommend a self-cleaning filter. Why? Because this self-cleaning filters allow you to clean the filters during the operation period only. Why it is important? Because if you are not using self-cleaning filter on your machine, then you must be using cartridge type of filter. The type of filter is not for a longer time. If any solid particle stuck to the filter element, you need to replace or maintain the again the repairing and everything. My colleague Nitin will explain detail on this topic.
Basically, these filters, cartridge type filters, we need to open the filters, clean it, and we can again use it. But to have a long run and to have a maintenance-free operations, it is basically with this kind of filters, you can just rotate the wheel, and within a second of time, you can remove the crystals and the wastage particles from the downside of the filters. In basket type or cartridge type filters, you need to completely open it. You need at least 1 hour or 45 minutes to clean and again reassemble. So to avoid this kind of downtime, we recommended to use self-cleaning filters, whether it is a wheel type or a motorized type. So we can provide or we can supply both type of filters. We can move to the next thing.
Again, we'll see a detailed discussion on filters also in our next slide. So next move to the flow meters. Flow meter plays an important role in high pressure machine overall controlling. This is the flow meter which we are using in our machine. Basically, it's a Europe German make flow meters. We'll also talk in detail how this flow meter work, how it is connected to the automation or closed loop system in our next slide. So this is just an introduction for of the flow meter. Let's move to the high pressure valve. This is the main component in high pressure, and this allows you to run the machine in low pressure and high pressure machine. We'll see high pressure cycle, correct. We'll see how this low pressure and high pressure cycle work in our next slide. Uh, then move to the mixing head. As I told you, this now new generation mixing head is developed on the technology of impingement mixing, and this kind of mixing head is so precise than low pressure. We'll also have a brief discussion about this mixing heads. Here I'm just giving you, as I told you, an introduction of all the components. So this is the mixing head, how it look like. Let's move to the next slide. One more thing, the hydraulic unit, which is used to control the piston of the mixing head. If there is a one piston or two piston, all the piston on the mixing head is controlled by the hydraulic unit. So this is the main feature of the hydraulic unit in the machine. Next, will just a second. Just a second. Sure. Just again, some technical error is there. Just a second. Okay, my presentation is visible.
Yes, sir.
Okay. Okay. So let's talk about how this high pressure machines work. I will show you one animation. This will give you a very good idea, and it will help you to understand how machine work in a low pressure cycle, how machine work in a high pressure cycle, and how machine is working during the pouring cycle. Means when you are pouring the chemicals into your mold or whatever it is. So if you see this is the polyol tank or isocyanate tank, which is pressurized by air pressure or nitrogen pressure, dry air pressure or nitrogen pressure. It's go through the pumping group. Then it is after pumping group, it is go to the high pressure valve and return back to the tank. So this is the chemical flow or liquid flow during the low pressure cycle. If you see in low pressure cycle, this line or this chemical is not going into the high pressure line, and our pump or motor do not require to work hard or to take additional load for the low pressure cycle. Then when machine goes into the high pressure cycle, if you can see now this earlier in our earlier side, this high pressure wall is open. That's the reason it is going through directly to the tank. If you compare this low pressure cycle with high pressure cycle, you will realize now in high pressure cycle is this high pressure wall is closed, and because this wall is closed, chemical or the liquid forced to go through the mixing head. Because it is going through the mixing head uh, to the tank, this calibration, there is a phenomenon called calibration. This is also plays a very important role during the calibration cycle. So how this work, you can see this chart here. This red line indicate when machine run in a low pressure cycle. When you press a pouring button, or when you want to start your pouring, machine automatically goes to high pressure mode. How? By closing this valve. Once this wall is closed, machine goes to high pressure, then the pressure of polyol and iso will increase, and now machine is ready for the pouring. So whatever shot you need to take, now this is you can plan for the pouring of position. because of this high pressure cycle. See, this is the pouring cycle. Now you have press and this mixing head piston is moved. Now there is a like way or path available for liquid to move through this mixing head injectors. So now this is in pouring cycle. Here in this graph you can see first machine was in low cycle, then high pressure valve is closed, machine went to the high pressure cycle. During the high pressure, mixing head start working, means pistons moved and create a space to move this liquid and for the impingement mixing. Through this pouring is happening. Whatever shot you need to take during this high pressure cycle, you can program and you can take multiple shot during this high pressure cycle before it is again going back to the low pressure cycle. In our next slide, we will also explain how this entire cycle for low pressure going machine into the low pressure, then high pressure, again coming back to low pressure. We'll show you this phenomenon also in our next slide. So I hope this low pressure and high pressure cycle will give you a basic idea of high pressure machine, how this machines is working in low pressure and high pressure machine. Now the main point of our entire webinar, like how to select the right machine for your application or your product. For this we need to consider multiple things, and why this is important to select a right machine configuration for your application. Because if you select the right machine configuration based on your application, you will have a very good quality product. You can have a better control on all the parameters which is required to be in control or during the production time, like short weight ratio, temperature of the both the chemicals. These kind of parameters you need to be have in control to get a good quality of product. Even if you refer any chemical supplier TDS, technical data sheet, there they are mentioning a working range for this kind of any kind of polyol or isocyanate. They are mentioning some working range, like this is the temperature range you should need to be maintained to get a high quality of product, or this is the mixing ratio you need to maintain on your machine, or this is the temperature, or this is the flow rate you need to maintain on your machine. So if you maintain these parameters, definitely or automatically you will get a good product. To get a good product, it is very important to select a right machine, because if you select a right machine, you have a good control on all the parameters. If you do not choose a right machine according to your application, it will definitely not give you a good control on the all these parameter which I discussed just now. So once you have a right machine configuration, it will give you a it will ensure you uniform mixing of both the chemicals, accurate dosing as I told you, the short weight, and the precise temperature control, leading to the consistent product quality. It is very important if your plant or if your factory is running more than one shift, two, three shift, three shift, then for a longer period of time, it is quite critical to maintain this parameter. So if you have this kind of control in our hand, it will help you to run your production for a longer period of time, two cycle, two shift, three shift, like that. This product quality also, like multiple time we are seeing this kind of problem from our customer during the production. For example, a flexible foam. During the production of flexible foam, customers are getting problems like air bubble during the production. So once they open the mold after the curing time, when they extract the product from the mold, they see there is a air holes or air void that are present in the product, which is basically they are degrading their end product quality. So if you have a right configuration, again you will have the control on this kind of things on the machine. Next, uh, operational efficiency. It will also allow you like properly selected machine optimize cycle time. For example, see, if you want to produce a product of 500 gram, and you have selected a, let's say, a smaller machine, and the highest capacity of that machine is to give you a short weight range of maximum 300 gram per second. So you need for 500 gram, you need to have a multiple second shot. uh, I'll reform this example. For example, you have selected the machine which can maximum give you 100 gram per second output, and you want to achieve or manufacture a product which is of 500 gram. Then you have to take a 5 second shot, 100 gram, 100 gram like this. So, but if you choose a right machine, you can also make a product of 500 gram in 1 second. So this is just an example. Based on this, you can assume like if your machine is smaller, you can require a longer time for the pouring, which automatically leads to a longer cycle time. This longer cycle time automatically lead to a less productivity in a particular time. Similarly, if you chosen a big machine and you want to produce a small part, something like 50 gram, 70 gram, then this lowering down this short weight of the machine, it is having some limitations. So you cannot not make the product of 50 gram. So it is very important to select a right machine range based on the product which we are going to manufacture or in and manufacture now and your near future. So this kind of thing will help you to select the right machine. Then uh, if you talk about the ratio also, this is the example I have given you for the short weight. Similarly, you can imagine the things for the ratio. If your chemical supplier is asking to maintain XYZ ratio and your machine is not able capable to maintain, then also you will have a problem. So that's the reason it is very important to select the right machine depending upon the product what you are going to manufacture, depending upon your future product which you are targeting to manufacture in next 2 3 years or 5 years. Also the automation part or how your machine is going to be smart. Choosing a smart machine also plays a very important role, because nowadays all the uh, uh, things are going through the smartness of the workability. So how automized your machine is, how it is controlling the output automatically without any human interference, how it is controlling the ratio, how it is going to control the machine temperature in automatic way. This is also plays a very important role. So uh, on this topic also we will discuss about in our next slide how what the automation is necessary, not for the over engineering, what the minimum automation is needed in the high pressure machine. Then again, if you use right machine, it will give you a long time production capability, and also it will give you a right production time, less downtime, this kind of thing. So now now let's discuss about the what are the points, what are the points to be considered while machine selection. Now, before this, we have gone through the why it is important to select the right machine. Now, I'm focusing on what the points we need to consider during the machine selection. So, first thing is uh, your machine, as I told you, fundamentally have all the parameters to control the things like ratio of the component A and B. If you are using two component system, then your machine need to be capable to handle the ratio of the uh, component A, component B. Again, it is well capable to handle the weight of the component A and component B. Viscosity again plays a very important role. In few application, viscosity of polyol is very much on higher side. So before finalizing the machine or before selecting the machine configuration, it is very important to see the polyol viscosity and also the iso viscosity, but most importantly the polyol viscosity. The product which you are going to be manufactured, for that particular product, what viscosity of polyol is available in market. Generally, if you select any category, like any right like chemical supplier, they can give you the range. You can compare that range with the other supplier. So you will have a good uh, idea about the viscosity which you are going to be used in next 2-3 years. Based on that idea, you can decide or configure your machine configuration. Next is output. As I have given you the example of short size or long size, how it is important, why it is going to affect your overall machine configuration. So here also short weight is very important, cycle time is very important, and again what the productivity you are targeting in a one shift or a two shift. For this, machine output is very important. These are the few examples of like particular application machine for a particular application, what size of machines are using. So generally, when we are going to our customer, they specifically ask me, Ravi, how you decide the machine size? Like there are machines available from 5 kg per minute to 200 kg or more than that also, 200 kg per minute. So how you are deciding the machine capacity? So again, the same answer, whatever the product customer is going to or targeting to manufacture, we need to understand the range, and accordingly we have to decide the machine sizes. For example, in a very general concept, for flexible application means those who are manufacturing product like office chairs, then
Those
uh,
memory foam pillows,
memory foam pillows, or
automotive.
many support kind of structure in this flexible foam. This kind of application generally require 10 kg per minute to 60 kg per minute of output. Within this range, most of this flexible foam application covers. Means you can manufacture this kind of product. If I talk about the skin, integral skin, generally this kind of product people are used for the armrest or headrest on the wheelchairs. So this kind of products are very small. So you not required a big machine or big output machine for this kind of product. So 5 kg per minute to 20 kg per minute machine is more than enough for this kind of application. Again, rigid panel in rigid application, for example, panels. In panels, people are manufacturing smaller panel also, say 1 meter, 1.5 meter, and bigger panel also like 12.5 meter. So in panel there is a huge range. So based on the size, what customer is going to manufacture, size plus the thickness. Based on these parameters, customer can decide what is the best machine size for their application, considering the length, width, and the thickness. One more important point during this machine selection, during machine output selection, the curing time. Means there is a concept called cream time. If you refer any of chemical supplier technical data sheet, there is a concept called cream time. Cream time plays a very important role in selection of the uh, machine sizes. Why? Uh, because for the different application, this cream time varies from 8 second to 50 second as well. For example, for flexible foam, generally it is 6 second to 8 second. For rigid form application like panel and all, it is more than like 30, 25, 30, sometime it is 40 also. So the idea is whatever your cream time is, for example, imagine your cream time is 30 seconds. So it is very important to complete your filling time or your injection time before your cream time. Why? Here I have mentioned, in order not to damage the structure of the foam during the blowing phase. Once this cream time crosses, the reaction of polyol and isocyanate start and foam started basically blowing. So whatever quantity you want to displace, this is need to be before cream time. Once is this blowing is started, you should not disturb the chemistry or the chemical phenomenon. The pouring should be always inferior to the cream time, as I told you. Permitting to pour liquid on the liquid. This will allow to stop or to secure the overlapping of the chemical, because for example in panel, if any place there is a overlapping in the both the place, so there will be a difference between the uh, like K value, thermal conductivity. To avoid this kind of scenario, this is very important to inject all the required chemical before the cream time into the mold or whatever it is. Uh, okay, so next uh, important factor is selection of mixing head. Okay, so as I informed you in my previous slide, there are two type of mixing head. One is a straight mixing head, which is having only one piston, and this kind of mixing head generally plays like used in the cavity filling application, where low output or medium output is required. So next is next is like high pressure. Let me just introduce just a minute. You can see this is the just a second. Okay, this is the straight head. How it works? Uh, this from here you will be understand. You can see here the piston is closed. Here the piston is open now. When piston is open, it is creating a space to move this polyol and isocyanate through injectors, and it will create, because of this high pressure, it will create a impingement mixing and turbulence that will mix the polyol and isocyanate. Similar way, the working of L type mixing head also. As I told you, this is a two piston having a two piston concept. Here you can see both the pistons are closed. Now one piston is open, cleaning piston is open. Now it is ready to for the pouring. Second piston is also open and now it is pouring. Once this pouring is done, it is closed by pouring piston. Then whatever the mixing happened in mixing chamber, whatever material is there in the mixing chamber, that will be cleaned through this mixing head. You can see here. So basically, this is the basic of how this piston mixing head work. Uh, Now let's talk about some significant or advantage in terms of and what are the difference between this. In as I told you, this straight head, this is a generally creating more turbulence as compared to the L-type mixing head. Generally, this mixing head is used for the rigid application where uh, this cavity filling kind of activity is done. Whenever we called about the flexible foam or memory foam, this kind of product, we recommend to go with the L-type mixing head. Also, for the panel also, we recommend to go with the L-type mixing head when it is not only the cavity filling and you want to produce a long panels or more thickness panel. This L-type mixing head ensure you for the high quality of the panel or your end product. Productivity you will get more in the L type of mixing head, and this is also allow you to increase your productivity by taking number of shot one after another. For example, for in the rigid application, people are using multiple molds. So with the multiple, if they are using multiple molds, they need to be take a shot within a some time, few second, the next shot. So this kind of L type of mixing head help them to take a shot in like 1 second, 2 second, one after another. This is the important of like difference between straight head and L type mixing head. But obvious laminar flow, which is very important to avoid the bubbles or avoid any unnecessary mixing of the uneven mixing of the both the chemicals. Laminar flow is required, and especially in the flexible foam. So next is our nozzle type. This nozzle, it goes into the mixing head where from isocyanate and polyol basically goes through. So this is, you can imagine this is a mixing head and these are the two injectors or nozzles. There are multiple type of injectors or nozzles available in the market. Generally, it's of two type, and it one is a static nozzle and it is a spring loaded nozzle. We call it a adjustable. This static nozzle is are like one of kind of fixed kind of nozzle where you do not have much option for the variation. But this spring type of nozzle will give you an advantage or flexibility to adjust the flow rate or the pressure as compared to the static. Here we can see in detail, like how and where we can use a static nozzle and a spring loaded nozzle. If you see the low output applications, or where this kind of quality is not so such important, you can use the static mixer. But if you want to have a good laminar flow, good productivity, and better quality, you can use a spring loaded. This is if you use spring loaded nozzle, this is widely usable for starting from the panel to the sitting application. So this is the difference between static nozzle and the spring loaded nozzle. And after this also, it is very important to select the right size of the nozzle. If you have not selected the right size of the nozzle, then there will be a multiple issues where what are these issues, let discuss here. Just a second. For example, if you select a very small, like 1 mm, 2 mm, based on the application, you have selected a small application, then there will be a two possibility. First, injection pressure gap is too small. Means where your polyol or isocyanate is passing through, that gap is very small. This lead to a not low mixing efficiency. Again, because of this low mixing efficiency, your end product is going to be hampered. Second possibility, uncontrollable pressure at the mixing head opening. Once your mixing head start pouring, there will be a uh, pre-flow kind of thing. Like you can see the separation between isocyanate and uh, polyol in your mold and your cavity. And the second scenario is, what if you select a big injector or big nozzles? Again, it will create a injection pressure instability. Because of that, your machine sometime go into the high pressure, sometime polyol pressure goes into high, sometime isocyanate, and machine will give you the alarm. This is one condition. Chemical overheating. It is also like if you have not selected the right nozzles, because of the friction your chemical is getting more heated. Then fluid speed too high, means turbulence at the starting of the production. Means when you press the pouring button, chemical directly splashes on your mold. This will also one type of problem because of the uh, nozzle selection. Uncontrollable pressure, heat. Again, it is like give you the same kind of condition like pre-flow. You when you see in the mold or output of the chemical, you can see the separation from your uh, ice. There is no proper mixing. So this is why selection of mixing head plus the selection of nozzle is very important. Now let's move to the next parameter, that is a closed loop system and real time monitoring. This is one of the most important feature in high pressure machine. What it does basically, it is continuously compare the real output and the set value, like whatever output you have set on the control panel, it compare it with the actual value and it is getting automatically corrected, automatically adjust of any possible deviation during the closed loop system. How it work, I will show you from this. I will try to explain you from this diagram. For example, you have set any value to the HMI. It will on the basis of that, it will it will go to your PLC. It will send signal to your inverter. Your inverter gives signal to the motor. Based on the motor, because motor and pump are connected, your pump is working. Then you will get some output in the delivery line of the pump. Then this flow is go through the flow meters. This flow meter measures the value in real time, and sends signal to the PLC. Then PLC compare the values, like what is the earlier set pressure short weight, or now what the differences between. If there is any deviation, it send signal to the inverter, and inverter send the signal to adjust the frequency of the motor. So by adjusting the frequency of the motor, it will control the output. So this entire process, whatever I have explained you, all this happening in a fraction of second. So within a fraction of second, all these values goes and every calculation is done, and within a fraction of second, your machine is ready to give you the right accuracy. Accuracy means you can consider accuracy of plus minus 1% if your this closed loop system is installed on your machine. So flow meter is one of the important part or important thing uh, in this closed loop time system. My colleague Nitin will explain you more about these things.
Basically, in all the European machines, you can have this automatic adjustment system. We called it as a closed loop system. And as explained by Ravi, all the things like the flow meter measures the flow and give the signal to PLC, and it automatically give a signal to inverter to speed up or speed down the motor. Based on that, output will also get adjusted from the pump side. So if you say, if you put 500 grams per second output, so machine will try to maintain the 500 gram per second output anyhow. So it will go just like 490 to 510, and it will maintain 500. Once output is mentioned, the ratio of the mixing or ratio of the machine like iso and polyol, it will be maintained automatically. And during the pouring cycle, if all these things are proper, like flow is proper as well as ratio is proper, the total weight you will get at the right ratio, and you will get proper weight in the end as per your set point. So to have the control on the ratio, output, and in the end on the weight of the product, you need to have this closed loop system in your machine. It is very important, very important factor to choose the machine.
Thank you, Nitin. Thank you. Let's move for the advantage. As I told you, ensure precise monitoring of the process parameter like flow rate, ratio, total weight, this kind of thing to maintain consistency in your product quality. Then immediate detection of deviation, as I explained you, help avoid errors and quality failure in the production. This is very important for a trouble-free operation at your factory.
In closed loop system, if there is any deviation from the pump side, if you're not going to get a proper ratio, if ratio is not matching as per your requirement, then machine will not pour the weight, means it will not work beyond that. It will give the error of out of ratio or out of output, and then it will stop. And you need to readjust the pressure as well as the output, and then you can restart again. So if there is any deviation in the ratio or weight or output, machine will stop. So it will ensure that you will not get bad quality product or scrap in the end of the application.
So because of this automation or this closed loop system, machine is adjusting so many parameters by itself without even a human intervention. So because of this, this worker can focus on other critical tasks which can help in improvement of the production and the capacity and all these things. So this is very important. With the help of this closed loop system, like your machine is well capable to manage all the parameter by its own. So it's like a very useful feature on the machine. Next, jump into type of metering pump. As of now, for high pressure machine, there are two type of pumps are available. Both the pumps are having a good working things based on their advantage and based on their need. Like first is fixed output pump. These pump deliver a constant predetermined flow rate. It means you do not have a much control on the output. You have only control of the output of this kind of pump only through the electronic control panels. You can see flow adjustment can be done only via electronic control like VFD, PLC integration, so, and like closed loop system. This is very simple design, and of course the price of fixed pump is lesser than variable pumps. Bed suitable for where flow requirement remain constant means if you sure about your product, what you are going to what you are going to be manufacture, and you have the this all the product in your range, there is no need to go with the variable pump. You can even go with the fixed output pump. Here is the advantage of variable pump. These pumps allow a user to use the flow rate during operation to match the process requirement. As I told you, because of variable concept or variable technology, you have a bigger range to play with the output. Here you have the flow adjustment can be done via manual wheel. This kind of wheels is available, and also through the electronic control system like here, which is available in fixed output. Means in variable output you have a two type of control on output of the pump. First is through the closed loop system or through the this kind VFD and all, and second is
Hello.
by adjusting the node.
Hello,
Yes.
Ravi sir.
Yes.
Yeah, this is just a time warning for you.
Okay.
We have,
Okay.
yeah, yeah.
Okay, I'll try to move fast because it is very difficult to cover all the entire range of the machineries in one presentation. I'll try to speed up a little bit. Okay, now as I told you, magnetic coupling, this is also a very important thing. Now I will not go into the working phenomenon. I will explain you why it is important to be have on your machine directly. Okay, why this is important and or what the advantage you will have if you have magnetic coupling on your machine. It will give you a leak free operation for polyurethane and MDI. If you are not using magnetic coupling, then you will use a radial seal on your machine. Radial seal life it not so long. It will be it may be damaged within a 6 month, 1 year, 1.5 year. We cannot predict. But this if you use high pressure magnetic coupling, the life of magnetic coupling is very long, and you have a maintenance free operation, maintenance free activity for a longer period of time. It is also give you a safe working condition with flammable like cyclopentane is used where it is used. So it is also give you a safe environment. Reduce the maintenance and increase the pump life. That is very important. Everybody is highlighting the maintenance free activity, but it is also increasing the pump life. So pump is again a costly item on your machine. So definitely you are saving some money if you are adding magnetic coupling in your machine. No need to keep any consumables like as I told you radial seal or any o-ring during the maintenance time of activity because of its long life. Let's move to the next parameter, that is temperature control system. We have multiple things present in our machine to control the temperature of the chemicals, like heat exchanger, and our we provide both the tanks with jacket. So jacketed tanks are there, tank insulation is there. We also provide a PT sensor for the closed loop system and to sense and control the temperature automatically through the PLC. Water circulation valve, which is help to circulate the chilled or hot water entire the jacket where it is necessary in tank or heat exchanger. Here you can see this is the basically jacket behind the insulation. This black color part is called insulation. Behind that water jacket is there. To maintain the temperature, we are supplying hot or cold water through the jacket according to the condition, like winter, summer, according to the condition we'll supply. And we have a fully control. If we achieve the desire or set temperature, machine have an automatic system to sense. It will unnecessarily not consume any additional energy to manage or to extra heat the or cool the chem chemicals. So these are the important thing you need to be consider for temperature controlling in the machine. Then we'll move to the level indicator. As I told you, we are providing automatic machine magnetic type. This is a long durable, and we can give you like four adjustment set point. From the HMI, you can control like what will be the minimum, maximum, start filling, stop filling parameter. It is totally a tailorized thing, and you can uh, set the parameter as per your condition or your requirement. So we have given this part open to the customer. You can easily select or change or modify from the HMI panel. This is visual color, so you can see the level quickly. Let's weight calibration system through mixing it. This is also one of the most important feature, because I have seen people are struggling while calibrating their machine. Because if the machine is based on the timer based, and operator need to calibrate the machine, then it is taking a longer time means half an hour or even more than that also. So if you have this closed loop system or the calibration system on your machine, you can easily calibrate a machine in a very short period of time. It is very simple process. Anybody who is operating the machine who can calibrate the machine. Now, because of the time concern, I will not going into the detail, but this is you need to consider most important thing during the machine selection. Okay, let's move. Holiday cycle. This is also a very important feature on the machine. What it does basically, whenever for a longer time you are not using your machine, for example 4 5 days or more than a week, then this uh, holiday cycle allow you to periodically run low and high pressure cycle during the non-working period. Means you have to give power only to your control panel, and this is fully programmable operation. You can set whatever, what is the idle time, what is the low pressure cycle time, what is the high pressure cycle time. You can easily program these things. What is the advantage of this? Because once it is going to the low pressure, it will start recirculating the chemicals, and because of the recirculation, this settle down of pigments or any crystal formation on isoside is not happening. It will also go to the high pressure mode. As I shown you previously, once machine goes to the high pressure, the entire flows goes into return from the mixing head. So your complete line is getting recirculated. So there is very no chances or very less chances to get any crystallization or any settling of pigments. So whenever you come back from a long holiday, for example, after a week time, you not need to check the machine parameter. Your machine is already in ready condition for the production. So this is very important feature I should recommend to also consider during your machine selection. Self-cleaning filter, as I told you, self-cleaning filter are the advanced filtration system designed to automatically remove solid particles from the liquid, ensuring the efficiency. Because as previously explained, very no additional time required to change the filter or change the cartridge. I'm moving little fast now. Uh, this is one of the main important feature also on the machine. Basically, it is the data acquisition system. This system collect all the information of the day by day activity. Like in a particular day, how many shot your operator took, how many successful shot, what was the ratio, what was the set value, what is the actual value. Every parameter is machine capturing and storing in its memory. And if you want, you can pull out this information or this data through a USB. You can take this data into your computer system, desktop, laptop, and you can use this data for your sales plan, for your production plan, and for the comparison of the productivity. So this is very important feature for the understanding the how your factory work or how your people work, what the production they are taking, at what time, how many shot at particular day, how many product you produce. This will help you. It will also give you the possibility to check the alarm history. For example, within last few days, if your machine has given any alarm, so you can pull out all the alarm history, you can check the parameters, why this alarm come. You can send this alarm history to your machine manufacturer. They can diagnose or they can suggest you this is because of XYZ reason you need to do this, or you need to take an extra precaution or so. So this is a very important feature which is available on all you most of the European machine, and we should recommend you to always take these features into the consideration while machine selection. So these are the points you need to consider. Uh, because of limited time, I tried to cover maximum point for the selection guidance of this machine. Now I will take your 2 minutes only to understand or only to explain you the innovation going to the global market. Now, people are started working, European companies started working, or they already have Industry 4.0. This is basically a advanced version of automation system. So because of this, you will get an online supervision platform. With the help of this, uh, you can like monitor, analyze, and optimize the production process in real time. So this will give you a capability to see or to check the parameter through the internet or from anywhere. Like there is no any limitation. You need to go to the factory. This kind of thing. It also help into the error deduction during machine breakdown through remote support. By sitting here, I can support you uh, to you or your operator which is nearby your machine, and I can guide you from here to diagnose any breakdown problem. This is the advantage basically. And also advanced data acquisition system. Whatever the data acquisition which I discussed in previous slide, all these data you can access through the internet. So no need to go to the machine panel. Also you need to you will have the access to the all the parameter through the internet. So in real time, that's correct. That's the beauty of this industry 4.0. Also it will help you the predictive maintenance. It based on the some sensor. It is how it works, data driven and sensor based technique. It will help to identify the failure or anything going to be fail in future. So it machine will give you the alarm or a signal. You need to check your motor. There should be a possibility to any maintenance kind of activity from your pump side or motor side. So this kind of predictive maintenance alarm machine will give you this. If machine can give you this kind of alarm, you can schedule your maintenance activity, you can reduce your downtime, optimize your production, and extend the life of the machineries. So if machine can give you the alarm, you can schedule your parameters when after 2 days, 3 days, or immediately you can decide like you want to go with the maintenance or not. So that's it from my side. Thank you everybody for the attention. Any question you can ask now to
Thank you,
me.
sir, for this insightful presentation. And we have a question in the chat box by Mr. Kunal Soni. Air bubbles can be caused by mold flow irregularities. Also, how do we differentiate between air bubbles caused due to machine or due to irregular mold flow?
Okay, I'll answer this question. Whenever this pouring is happening, you can see the really immediately at the time of pouring, you can see in your mold if there is any bubble creation or any bubble present in your initial mixture of polyol or isocyanate. So you can like calculate this is something wrong with the mixing head or something wrong with the nozzles. uh, this you have to check because before the cream time. If cream time start, it will get foam will get like foaming started, then you cannot have a clear vision or visibility to see this thing. So you need to take a close look of your chemical mixture immediately after the pouring before the cream time. If there is bubble, there is something some issue with mixing head or the nozzles.
No, so is it the nozzle size or is it the mixing head has some problem inside? There is gaps inside. So how do we detect that? Like,
Basically, sir, we have to mention the right pressure as per the necessity, whatever the data sheet mentioned, like 120 or 130 bar. If the pressure is properly maintained, if ratio is properly maintained, and at the end of the pouring, if you find any bubbles in the mixture, then there is a possibility that the flow is turbulent. So we need to adjust the pressure little bit. If the still pressure is turbulent, then that is the problem of mixing it. If the mixing are properly selected, if the nozzles are properly selected, it should give you laminar flow. And if there is a laminar flow and all other parameters are maintained properly, you should get the right product. If this kind of things maintain and still you have the problem of bad quality of the product like air bubble or any air pockets, then you need to look at the mold side or temperature of the mold or any there is a irregularities in the mold of flow of mold.
so is there a thumb rule for like deciding that we have to increase pressure only to reduce the air bubbles, or we can decrease pressure also to reduce the bubbles formed?
It depends on what is happening there. If the only the air pockets are there, and with the increasing or decreasing the pressure, if you are getting the good results, then that can be done. But if there is a problem from the mold side, whether you increase or decrease pressure, it is not going to help you.
That is venting issue. I'm talking about the air bubble from the mixing head.
Yes, for air bubble from mixing head, you need to have a laminar flow. Every OEM or every machine manufacturer give you the range of laminar flow. Like if you have a machine of 40 kg, you should have a flow between 250 to 300 grams. And at that flow, your machine or your mixing head will give you laminar flow. If you have a higher flow, then there is a chances of turbulence. If you have a small nozzles, then there is a chance of turbulence. So we need to select and we need to properly maintain these things.
Understood. Thank you. Thank you so much.
Okay, there is another question. How to incorporate fillers in high pressure machine?
So basically, these machines are not designed for fillers. For fillers, we need to have a different kind of mixing aids where we can add the fillers in the end of the mixing. But these mixing aids or these machines are not capable to have a fillers.
Okay. So there is a hand raised from Mr. Abdul Jabbar. Sir, you can unmute yourself and please ask the question.
Hey, this is Amanullah from Honeywell in Dubai.
Okay.
I have two questions to ask you. One is that you said about the two-component machine, only about the injection machines. You also make the press and everything for the panels?
Yes.
So if you have a customer who wants to go for a complete panel plant, you can supply the injection machine as well as the press and everything. The complete turnkey project, I mean.
Right. We can supply, sir.
Okay. And the second question is that you make only two component machines, or you also have a blowing agent mixing line also, which can be incorporated separately through a static mixer.
Yes, that is called a premix system, or
Yeah.
different machine where polyol and cyclopentane or other blowing agents can be mixed at a precise ratio, and then
Okay.
that will go into the machine day tank. So that is called a premix system. We can supply
Right.
that as well.
Okay, great. Thank you so much. Nice presentation.
Thank you, sir.
Thank you.
Thanks.
Any more questions?
Okay, and one more question is there in the chat box that they need to have a high-speed machine for R&D lab level. So is there any suggestion for them?
Yes, we can supply R&D lab as well, R&D lab machines as well, where we have develop a machine which have a smaller tanks like 50 liter tanks, and a smaller and portable machines where you will get the high pressure mixings and everything as per the presentation. But with the smaller quantities, you can have a small batches and small shots as well. So details can be sent to you over the email once the presentation is over.
Okay.
We have can the TDI tank to be cooled with water cooling jacketed tank. Yes, we can cool and maintain the temperature using the chilled water in the TDI tank as well. But with only jacket, it will not help. We need to have a heat exchanger like shell and tube heat exchanger or plate type heat exchanger, and it will be incorporated in written line so that there will be no pressure peaks. And we also suggest to have one pressure gauge or pressure transmitter in the end of before the entry of the return line into the heat exchanger to avoid the damage of heat exchangers. So you can cool the TDI, MDI tanks with the help of water.
Thank you, Mr. Ravi. But is there a risk that we have in terms of safety? You know,
if you're going to use the water and if there is a jacket failure or shell get damaged or heat exchanger got damaged, there has been incidences where isocyanidine or MDI, TDI mixed with the water, and there is a complete damage of pumps, all the critical items.
Right.
But
right.
if you want to have a right temperature, we need to use a chilled water. So basically, we suggest to have a higher thickness tanks where you will have like 10 mm thickness of the shell as well as 8 mm thickness of the jacket. And with that, and with the shell and tube heat exchanger, which is more reliable than plate type heat exchangers, you can have a higher thickness of tubes. And with that, you can make sure that it will not damage. And we recommend to have a 2 to 3 years maintenance of that heat exchangers. And after 5 years, we recommended to change the tanks if you don't want to risk your machine.
Thank you, Mr. Ravi. I think that helps.
Okay. So another question is, we are facing a problem of weight variation, but chemical calibration is okay. How we can get the set pressure?
I think the question is like, we are facing a problem of weight variation, but chemical calibration is okay. How we can get the set pressure? So the question is little bit mismatched, but let me explain you. If there is a weight variation and if you have a flow meters installed in your machine, then you need to do the calibration. If after the calibration you are getting the right weight on the both side like polyol isocyanate, and then you have a pressure variation issue, then in that case you need to check the nozzles, the return line, and if there is any crystallization or any problem in the supply return line. But if calibration is okay, there should not be a weight variation. Yes, there may be a ratio variation due to the pump side if there is flow meter not installed in the machine. That's why we recommended to use flow meters like a closed loop system. In that you have automatic weight and output optimization, and you will get the right ratio, right weight, and right output in the end. And the pressure can be increased due to various things. So we need to identify where it is increased and at what time it is increased, whether it is increased during the high pressure cycle or during the pouring cycle, that we need to understand. After the presentation, you can just call me or Ravi or put up a mail. We can have a one-to-one discussion and try to solve your problem.
Yeah. And there is one inquiry. We have inquiry for gel infused molded foam. So
Yes,
any suggestion for them?
yes, we can supply that as well. After the presentation, we'll send you the details on your email.
Sure. You can send us your inquiry through email.
Yeah. Okay, sir. In the chat box, there are no more questions. So let us thank both the presenters for this very informative presentation and very detailed presentation, right from the working of the machines, then advantages, disadvantages, and the innovations. Thank you so much, sir, for this very informative presentation.